Okay, this is done. We call this phase folded. And we have phase folded with 4 million events from the little Pulsar and the surrounding region. So let's move on to the next step and make use of this data. Okay, so let's have a look at our data. The first thing we should notice is that Templitude, the Framing plugin, has added a column to the FU1 file called pulse phase by default, although you can call it anything. And this is a number between 0 and 1, which again tells us where the neutron star is in its rotation. It's going to be what we use to plot the pulse profile. And then we see our other little friends, the energy here and the time. What this function is going to do is plot what we call the pulse profile. So we're just going to take this phase. We're going to select energies greater than 1 GeV again, just to speed things up a little bit. And we're going to just make a histogram of the spin phase, because it's a number between 0 and 1. We just use bins that are defined between 0 and 1. Halo is very bright, so we'll use a decent number of bins, 200. We can use more, it's fine. And the other thing we're going to make is what we call variously a phasogram, a waterfall plot. But it's taking the plot that we'll make in the first plot and then extending it to another axis, that of time. We're going to do this to make sure that our ephemeris is good for the entire length of the data and that we don't see the spin phase drifting in time. You see that? So let's just go ahead and run this, and I've done that here. Plot the first pulse profile. It takes a little bit of time to come across my network, so I have them off screen, wings, and these are the two figures that this command generates. First we have the Pulsar pulse profile, and it's absolutely beautiful. This is just one of the greatest pulsars in the sky. It's got a classic pulse profile for gamma ray pulsars, 2 main peaks with enhanced emission in the middle, and then this is a background level that's typically the combination of background sources, but sometimes it's also from the pulsar. And you can see it's very bright, but also that it's kind of confined to phases from about 0.1 to 0.65 or so, 0.63 maybe. So this is what we call the on pulse, and this is what we call the off pulse. And obviously if we can only select the data from the on pulse, we'll have a data sample where the pulsar is very bright, and a sample from the off pulse, the pulsar will be very faint or possibly even absent. Now this is that phasogram that I told you about, which shows the pulse phase as a function of kind of calendar date, in this case modified Julian date. And what we see this big hole in our data set for one thing. That's a little strange, but let's not worry about that too much. What we see is that this is our pulse profile. So this is that first peak, Q1. This is that second peak. And we see that as we go forward in time, those are just rock solid at the same phase. This is what I really want to see. There's this missing data, which I don't understand, but it doesn't matter. And then we come back after the missing data. Everything's fine until we get to this point. And then it all kind of goes crazy. Everything is smeared out. We no longer see the nice pulse profiles. So it would not be able to do this type of on-pulse, off-pulse separation here. This is because our ephemeris is not good at this calendar interval. And we can see this actually if we looked at the ephemeris that we used. It has these keywords called start and finish. And these are typically used to define the range of validity of the ephemeris. But you cannot take them for granted. You should always look at your data and make sure that those two keywords make sense. In this case it does. It says that our ephemeris should finish up at MJD 58487, and if we zoom in here, we see that indeed, sorry about this stuff up here, we see indeed that this phase is rock solid up until that point, and then it begins to drift. This is where our ephemeris is still extrapolating, but not very well, starting to go off, and then it just really goes crazy. And what happened here is actually, this is another of those glitches that I mentioned, where the rotational phase of Vela changed very suddenly. And this just causes the ephemeris' prediction to go radically wrong. If you squint at this, you can actually still see, because Vela is so bright, even though the ephemeris is very, very wrong, every now and then it comes back into phase and you can actually see the pulse reappears. It happens that on these days, that ephemeris is predicting the right spin phase, and then it gets wrong again and goes crazy. So at this point, you would either need to truncate your data just to the set that it's time range that is good, or extend the ephemeris, or probably more realistically ask your friend to extend the ephemeris, and then you can repeat this exercise with a longer time range. Alright, now let's see how powerful this on-pulse, off-pulse separation can be. We're back to our make counts map function, so we can look at the distribution of photons on the sky, and I've added some features to it. keyword argument for onPulse equals true or onPulse equals false, which will divide the data into two sets. And you'll see I've also modified load event data to get the extra columns, pulse phase and the time. We do our 1 GB cut as before, and then in order to separate the data into on-pulse and off-pulse, we can look back at our pulse profile and kind of identify a place where we think this has gone down to pretty much no pulsed emission, and the same on the other side, and that defines cuts of about 0.09 and 0.64. The Pulsar is not going to be entirely off with those cuts. This is really a decision you have to make as a data analyst, how pure you want your data set to be. Obviously, the further out you go, the less pulsed emission you'll have, but the fewer photons you'll have to work with. It might make sense to optimize that selection with some simulations. But I've kind of picked these just for illustrative purposes. So we're going to take all the data between 0.9 and 0.64 as on pulse, and the complement of that is the off pulse. And because we saw that our ephemeris is not good after MJD 58487, we're going to apply an additional cut to exclude all of that data. Again, if you needed to use data beyond that date, you would need to get a better ephemeris. Okay, so in these things you recognized before, we're just loading in the data and applying our masks and converting to galactic coordinates. And now the only thing that's changed down here is that because the on-pulse has so many more photons, it's got all of the photons from that really bright pulsar, it's not going to make sense to use the same range for on-pulse and off-pulse. So I've adjusted it to better show you the difference between the two, and everything else is more or less the same. So we can invoke this, make counts maps. Let's do it with the on-pulse first, which you've already seen. So this is going to look pretty similar to what we saw before. And I'm going to cover up the previous plots. Just these now. I think I probably have them in the wrong order. There we go. They will eventually appear. Nope. There they are. Okay, so this looks familiar. I'm going to go ahead and actually make the others so I can talk about these while we render the screen. This is the same plot we saw before, except the pulsar is actually even brighter to the other things because all of its counts are concentrated in this one half of the data. And here's that same slice in galactic latitude, -3 galactic latitude going across galactic longitude, showing again very bright yellow pulsar, maybe this little hint of something here, and you just can't see anything at all on this pulse rings. Now we've made our counts map on the off-pulse region, and here is what the sky map looks like. And this is quite a difference, isn't it? I left a little bit of the pulsar in so you can see it here, very faint in the middle, but it's pretty much gone. It's no brighter than any of these other sources. And lo and behold, there's a source right here that was indeed hiding in its shadow, and we can see these other sources much more clearly. This is even more apparent if we take longitude slice, and again, this is the Vela pulsar, this little peak right here, and here's another source right next to it. You would never have been able to see it without taking that pulsar into account. Again, we can now see this source much more clearly without that background. That very long tail of the pulsar bleeding into the source really obscures its nature. So you can see that if you have a faint source, this is a really important technique to apply and kind of requires us pulsar astronomers to work together with other astronomers to get good results. So if you have any questions, look me up. I'm sure someone can put you in contact with me. My email address is just matthew.kerr@gmail.com, my name, and I'll be happy to send you additional pointers or send you an updated ephemeris if you need it for your analysis. So I hope you enjoyed this, and I hope you have a great rest of your day. Take care.